All right, welcome everybody here to Implicit Differentiation for here in Calculus. Oh, don't forget to like and subscribe ahead of time. Go ahead and do that now. Nobody's laughing. Got it. There's actually an audience here. We're going to talk about implicit differentiation. We have learned implicit functions in AP Pre-Calc from last year. I hope you remember them. If you don't, well, let's take a trip down memory lane. Implicit functions are functions where y is embedded inside of the x's within the function. Explicit, in order it says y equals or f of x equals because f of x and y are the same. So implicit differentiation involves a different style of differentiation where we actually have to show all of our work here. And you can't always solve for y, for implicit. Sometimes you can, sometimes you can't. So real quick, I'm going to show you some imaginary math we've been doing with calculus. So when we have y equals x squared, and I take the derivative of both sides, I would get dy over dx equals, and what's the derivative of x squared? 2x. There has been imaginary math that has been going on that I have not explained. We're actually doing 2x dx dx. That means you took the derivative of x with respect to x. And what does that actually equal? 1. So that's why I've been ignoring it. So this is why this is actually equal to 2x. Every time you take the derivative, of a variable, you should tag it, okay? Unless it's what we're taking the derivative of. I call it tagging. So every time you take the derivative of y, you tag it with a dy dx. So if I were to reverse this, and it's x equals y squared, the derivative of x is dx dx, which we would just say as 1. What's the derivative of y squared? It's 2y, but what did I say we have to do? Tag it with a dy dx. Okay? That's like the super simple version of what we're doing. All right, so implicit differentiation, you do have some directions up top. Differentiate both sides with respect to x, treating y as a differentiable function of x. We'll collect all the dy dx terms on one side of the equation and solve for dy dx. Okay, so for this first one right here, we're going to write the equation of a tangent to the circle. So just to remind you, that is y minus y1 equals mx minus x1. And we do have x1 as 3. We do have y1 as 4. So we already have two things. We need to find the slope. In order to find the slope, we have to find dy dx at 3, 4. So to find the slope, we have to differentiate this circle. So what's the derivative of this circle? Plus dy dx. Very good. Equals? Yeah, be careful. Some people, when they're going really fast, they kind of put 25 and that messes everything up. So this does equal 0 over here. Solving for dy dx, I'm going to subtract both sides by 2x. So I'm going to get 2y dy over dx is equal to negative 2x. Once we get here, divide both sides by 2y. So dy over dx is equal to negative x over y. Okay. So slope for what we have right here is going to be equal to dy over dx, where we evaluate x comma y at 3 comma 4. You see how I'm doing this notation? I'm putting x comma y because we have multiple variables here. Is that too small for y'all? I can zoom in. Got it. So what does this equal? You have 3/4. Okay, so let's go ahead and plug all this stuff in. I'll use a different color. Get nice and fancy here. I'm going to plug everything I have in here. So I'm going to do y minus y1, which I have as 4 equals negative 3/4 x minus 3. So if I were to draw this, by the way, this is a circle, if you did not know that. So here's a circle with a radius of 5. Let's just pretend that is a good circle. I'll put a big dot. There we go. Call that 5. We're evaluating right here at this dashed green line right there, and that does have a negative slope, which makes sense because my slope here is negative. This is a baby implicit question, by the way. Super simple. Questions on it? Just trying to get your feet a little wet here. Let's flip that page on over. Okay, so now this is an implicit equation where it's got a lot going on. So when we start doing implicit, start to look for product rule, start to look for chain rule, start to look for quotient rule. This one has two things going on. On the left-hand side, I have chain rule. On the right-hand side, I have product rule. So for chain rule on the left-hand side, derivative of the outside is cosine of x plus y. And then the derivative of the inside is 1 plus dy over dx equals, and on the right hand side we have our two functions. So y squared goes first, so we're going to go 2y tag it, rewrite, and the derivative of cosine of x is, yeah, make sure you put that parentheses out in front. Some people forget that parentheses and it looks like y squared minus sign. Don't do that. That's the hard calculus part, by the way. Here comes the algebra. That's where we struggle here. So what I want to do here is I'm going to distribute this cosine of x plus y so I can start to isolate this dy dx. So distribute. So I'm going to get cosine of x plus y plus dy over dx cosine of x plus y equals, the right hand side is pretty much going to stay the same. I'm going to move that negative sign out in front. So I'm going to get 2y dy over dx cosine x minus y squared sine of x. I want to collect all my dy dx's and put them on one side. So I'm actually going to abandon what I'm underlining here. I'm going to move that cosine x plus y on over to the other side. And I'm actually going to shift this term with the dy dx to the other side as well. So I'm going to subtract both those green underlined terms. So the left hand side is going to be dy over dx cosine of x plus y minus the green on the right hand side. So it's 2y dy over dx cosine x equals, on the right hand side I still have negative y squared sine x, and then I'm subtracting over this cosine over here to get minus cosine x plus y. dy dx's are on the same side now. That's what we want. Take out the GCF of dy dx. I don't care if there's more things to take out of this GCF. Only do dy dx so that we can set everything equal to dy dx. So I'm going to get dy over dx, parentheses. It's a lot of copying now. All right. Divide both sides by this cosine x plus y, 2y cosine y. Are there any questions as I'm writing this down? Because I was seeing who was paying attention, and clearly you have gold star for all of you. This should be an X right here. I'm not redoing the video. Staying in. Because it's okay for teachers to make mistakes too. As long as your students catch it. Alright, so what does dy dx equal? Negative y squared sine of x minus cosine x plus y all over. Alright, let's do this one right now. A little ugly, but that's what it is. Okay, probably one of the hardest ones you'll do. So we just did one of the easiest ones you'll do. We just did one of the hardest ones you'll do. So hopefully we can know how to do the ones in between that. Okay, I'm gonna add in a second derivative problem into this one. So look down here, find d squared y over dx squared in terms of x and y, and yeah, with this equation right here. So what I'm going to do to find the second derivative is find the first derivative, set equal to dy dx, and then take the derivative after that. Okay, so actually this is not a difficult implicit problem. So what's the derivative of the left-hand side? 8x 4y dy dx equals 0. And we can handle this, right? Dy dx is equal to 2x over y. We can handle that. At home, if you can't handle that, you want to like and subscribe, and maybe I'll make more videos for you. And put your favorite calculus lesson in the comments below. I don't know why. Just do it, and let's see how many comments we can get on this video. All right, once you're here, take the derivative to find d squared y over dx squared. When I do that, left-hand side, just notationally, will turn into the second derivative. Right-hand side is the, starts with a Q, rhymes with quotient rule. So take the derivative of this side. So first is first. We get 2y minus 2x. Derivative of the bottom is dy over dx. Why is it 2y? Because it's the derivative of the top. It's 2 on top, and then the bottom is y. That's y. And then all over at the bottom squared, so y squared. Is this in terms of x and y? No, so I have to do one substitution. When is that going to be? Yeah, substitute out this 2x over y in for there. I'm going to do that right up here for you. So d squared y over dx squared is equal to 2y minus 2x over y all over y squared. Okay, is that now in terms of x and y? For your response, you're done. Be done. Move on. Yeah, simplifying is such an opinionated thing. It's like your opinion if that's simplified or not. Just make sure your opinion says that's simplified. Multiple choice, they're going to clean this up a bit. They're a little bit nastier on that. So, I showed you this earlier. To eliminate fractions and fractions, just multiply every single term by what the denominator of the fraction side of the fraction is. So multiply every term by a y here, y there, and y there. That's going to kill those fractions. So I'm going to get 2y squared minus, the y's cancel out here, so I'm going to get 4x squared all over y cubed. Believe it or not, this would not be the final answer. This would be the final answer. Now, this isn't just some magic trick. I didn't just be like, let's make that a negative 9. Well, maybe it was a magic trick. Can any of you figure it out where that came from? Can anybody on the video, can you figure it out? And if you did, get somebody else to like and subscribe and comment that you solved it. Anyway, where did that negative 9 come from? Came from the original problem. Look at how sneaky that was. If we were just to negate the left-hand side and the right-hand side, that would give us that negative 9. Okay? For the second derivative problems, whenever they are circles or ellipses or hyperbolas or anything like that, any type of conic, they usually reappear in our final answer, which we can then rewrite. Okay? So that wraps up that video. Do not forget to like and subscribe.